Okay, I think we'll get started. I'd like to introduce Dan Nadasi. He's a software engineer at Google working on Maps, and he's going to tell us about the horrible history of web development.
Thanks. So, hi everyone. The idea for this talk was basically to to talk to sort of a browser audience about the experience of web developers through the browser wars. So, I mean, we all know the browser wars very well, particularly those of us who've seen like the browser development side of things. But I figured many people won't fully appreciate the kind of impact that this had on actual web developers who are trying to build websites on all of the browser technology that was coming out. And this is a critically important part of the story of browser development in terms of the APIs you're presenting, in terms of like how effective the whole stack is for making really beautiful like internet applications. And the second title for this talk is, I'm gonna let you finish, but IE9 is the best browser of all time. And I hope to convince you of this by the end of the talk, at least from a web developer's perspective, about why IE9 was just such an amazing moment for all of us. So who am I? As Shane said, I work on Maps. I've worked on a bunch of different things at Google, front-end and back-end. I mean, I've been developing web software professionally for around about 5 years, and that's important because there may well be details missing in this talk. I've done a fair bit of research into sort of the internet as it evolved before I started developing professionally. But if you have like contributions or spot errors or have cool anecdotes about the history of browsers as I go through them, then by all means point out what I've done wrong or things like that. It's intended to be a bit tongue-in-cheek in the sense that of how much pain. And this is basically where we start. Right now, today, we're in a pretty good place. As a web developer, I can write one thing in one browser and in another current browser have something pretty similar appear. And that in and of itself is huge. We have, a consistent API stack that does pretty much the same thing across, 5 different major browser platforms, each with several different major versions. But I'm going to take things right back to the beginning. So, we start we'll start at the beginning with the creation of the internet. So, as many of you know, at this point, there are no browser bugs because, well, there are no browsers. And in particular, when the first browser is created, there are no cross-browser bugs because you can't have a cross-browser bug without 2 browsers. So far, so good. The web doesn't exactly do much. You can kind of put text and links, and if you want to open an image, you can, but it'll open up in a separate window because that's how things work, and so on and so forth. And then is the sound okay? Yep, sorry. Okay. And then Mosaic launches. And so Mosaic is kind of, this amazing thing. It's got, cross-platform compatibility to some degree, and you all of a sudden get some actual, functional websites. Continuing on, we get HTML being created, Netscape Navigator launches, and sort of this is setting the stage for all of the things to come. Now, right now in 1994, browsers are still just kind of dumb content monkeys. HTML is little more than just a specification for kind of text and links and a few other things. And in particular, kind of the notion that the web would be a platform for applications and things like that hasn't really evolved. So we still haven't hit any sort of meaningful, big, meaty problems. At least I hope not. I couldn't find any references to cross-browser bugs in 1994. And then we start getting Internet Explorer and we start heading into the first browser war. So JavaScript erupts around this time, and this is where we really start to see things going horribly wrong. So one of the themes that kind of emerges throughout this talk, and I have to be clear that I've not been like part of the HTML standards or anything like that, but we start to see kind of browsers being developed as kind of one entity, and also standards bodies kind of both trying to keep up with what browsers are doing and kind of lead the way at the same time as development teams on browsers doing things much faster and implementing their own standards and conflicting with each other. So this is, you know, this is a huge problem. Sorry, I'm just going to see if this fixes the static.
Maybe the other end.
Sorry?
Maybe the other end, yeah.
Oh, I see. I don't know, it doesn't have a clip, so I'm like, I'll just hold on to it. Okay, so continuing on. So we start to get JavaScript. And one of the interesting things about JavaScript is that this is where it basically forks. Internet Explorer goes off with its version of JavaScript it calls JScript. I think it was originally called JavaScript, and then there was some sort of copyright complaint, and so it ends up being called JScript. But regardless, it's a separate engine, it's a separate implementation, and so on and so forth. We also see the advent of CSS. You can actually get t-shirts with this on, it's very cool. So not my joke. Okay, so now, these things of course do not exist in the form they exist today, but the web has enough kind of shape and meat to it that you can really get things details. If you implement something badly in one browser, or not even badly, just differently in one browser from another browser, things start to diverge horribly. One of the interesting things that I learned as part of doing the research, though, was it seems like, for the most part, as Netscape and Internet Explorer evolved, they kind of went step in step for the most part. Like there was a feature battle going on with Netscape, trying to stay ahead of Internet Explorer because obviously they had a head start, and with Internet Explorer forking Mosaic and then trying to build on top of it. But by and large, they had pretty similar functionality, and it sort of only really hits later when you see this big divergence of Internet Explorer from the rest of the browser world. But I do want to talk a bit about JScript. So those of you who've been doing web programming for a while will recognize this one. This is kind of one of the first JavaScript bugs that any web developer runs into. And that is that the array length, if you include a trailing comma on Internet Explorer, is different from the array length of an array on every other browser. Now, there's no particular reason to do that. IE's way is, in short, wrong. And this is one of the few cases where you can actually say wrong in this talk as opposed to just different. And there's some very interesting ones later on. But this is very cool because it's one of those things that seems really innocuous and easy to spot. And this is a theme going forward as well in like these constructed examples that I'm giving, but kind of when you skip over to a more detailed example of, kind of a natural programming construct, you understand how this could introduce very subtle and really important bugs into your program. So here we have an example of a big array. You've been a good programmer and you've put a trailing comma after each one, which amongst other things will save you one line of delta when you go back to edit it the next time. And in Internet Explorer, now you've got this update critical internal state thing being called with because you're looping over big array up to its length, which is one more than it should be in Internet Explorer. Now, if I recall correctly, this has changed in the spec recently, and now if you have a trailing comma, it's actually, the length is well defined, and then each extra trailing comma adds one to the length, except for the first one, something like that, which seems very silly to me, but now you start to see where I was going with the why IE9 is the best browser of all time. It appears a few more times during this talk. The other important thing to notice is the big difference between that number in the top left and the number underneath the line. This took 15 years to fix. I think the reason for this one was it was fixed in ECMA script 5, and IE9 was trying to be standards compliant with ECMA script, and so finally they sort of caved in and went, okay, well, we don't really have a choice now because we want to say we're being standards compliant. Because if there's anything Microsoft loves, it's being able to say they're standards compliant. Actually, being standards compliant is, you know, neither here nor there, but they love to be able to say it. So this is going to get a bit sort of deeper into the programming side. So here's an example of what in JavaScript we call function expressions. So function expressions are kind of these hairy little devils, which aren't really easy to understand even if you go exactly by the spec, and they're kind of nasty, but they're very useful, so they hang around. So in JavaScript, there's a difference between a function expression and a function declaration. Sort of you can basically assign a function to a variable. That would be an example of a function expression, which is in line 1. Or you can declare a function. And in practice, there's very little difference between these two almost always. So, you know, I could call function f2 as a function the same way I would call var f1 as a function. You know, very little difference. Function f3 is an interesting one. So this obviously looks very silly. In the spec, what's meant to happen here is you just get var f3 and you're able to call f3. The reason why it has this extra name g is in case you want to do cool things like recursion. So within the scope of the function, you can refer to g itself. So you can say function g, call a function g, pass in a number n, and within there, call g of n minus 1. So, you know, if you wanted to do something recursive. So that's the point of a named expression. You're assigning it to a variable, it's still an expression. So the general rule of thumb is anywhere where you'd have a function in context as a sort of an assignment, that would be an expression, and anywhere that you see just a function declaration, that's a declaration. So we'll walk through a couple of examples. So here in the F5, we have an example of a function. All you've done is take the function declaration from line 2 and wrap it in brackets. So naturally, exactly as you'd expect, this is an expression, because why not? On the next line, where you've got a function declaration nested within a function within a pair of brackets, it's of course a declaration. Now, why exactly these would be the case is an obscure part of the ECMA script rules, and that's basically the only difference between the declaration and an expression. It's a pain. So, yep.
Is that because declarations get hoisted?
I mean, the explanation as it was, the question is that because declarations get hoisted? The explanation, the technical, like, what's happening under the hood in the spec is that it's only a declaration if it's within a function body or within the program. So this is why it's a declaration. As for the rationale for that, I don't know. Okay, so here's an example of where it actually makes a difference, whether your functions are expressions or declarations. Function A is a declaration. So essentially what's happening here is hoisting is the first pass of the compiler, if you like, or the interpreter will give you the function name A and mean it's called program. So you can refer to A above its declaration. B is an assignment or an expression, well, the function is an expression, so you can't refer to it above where it's declared. This is by the spec. So like this hasn't even gotten onto the topic of cross-browser bugs. This is just a huge pain if you're a web developer. And the common example is you've written a big script, you say put your private functions down the bottom because you're trying to keep your layout consistent, and maybe put your sort of visibility, your things which are all private visible together, or effectively private visible, I should say. Then by accident you've actually made one a declaration instead, an expression instead of a declaration, and all of a sudden your script fails because your function symbols aren't available where you expect them to be. So this is a huge pain, and this is by the spec. Now let's throw in JavaScript. So here's an example of the case from a few slides ago. So this is var f3 equals function g. What happens here, Internet Explorer actually leaves the symbol available after you've declared the function. So not only do you have, so type of f will work and it'll say function, type of g will also work and it'll give you a function. Okay, this isn't so bad, it's just an extra symbol that you have lying around that you might accidentally call. Maybe not so painful. Of course, Internet Explorer also treats it as a function declaration, so it still works even if you call it above where it's declared. So even though it's an assignment, so type of f here would not work because f is an assignment, type of g works just fine. Alright, still not so bad. Okay, it's probably not that much worse than the spec. This is where things start to get really hairy. There are actually two function objects here, which is probably not entirely surprising at this point. Now, those of you who have been programming for a while will probably smell something is up here. If you have a single function assignment that's accidentally creating two objects, this probably smells like a memory leak to some of you. So, sure enough, is a memory leak. So if you, in versions of Internet Explorer up to IE9, if you try and perform this assignment, what happens is the function g, both functions g, so one of them is trapped within the closure that's defined by f. So all of a sudden, oh, I think I've put in an extra pair of curly brackets there. No, okay, it's good. So your function g has been declared, it remains in the closure of f, and you've all of a sudden got this extra function flying around that can never be cleaned up until I think it's even if f is deallocated, but we might be lucky and that might be fine. No, I think if f is cleaned up, your g is fine. Okay, eventually fixed in IE9. So, sure enough, I say fixed because, as I've already explained, the spec is stupid. And which brings me to an important point from the perspective of a web developer. You do want to put a lot of considerate thought into the spec. In this case, the spec is like, it's no worse than your normal programming language bugs. I mean, if you look at Java, it's got crazy stuff like this. If you look at Python, it's got crazy stuff like this. But, you know, it's still not something you want to put up day to day as a web developer. There's also all of these things that are really hard to keep track of across browser. So there's some basic functions. In this case, I've used the example of array.indexOf, where the browsers decide that, okay, well, we'll provide this really handy piece of functionality and extend what's officially defined in the spec. And some, you know, obstinate browsers, i.e., will not implement the same functionality. So you end up in this place where, okay, I've got this array.indexOf function. It almost always works, except in the case that it doesn't. And to me, like now, I know the traps in the ones I'm used to. If I come across a new function and I think, oh, this is brilliant, the first thing I do is I look up the browser compatibility tables because I can't actually trust that everything is implemented the same way everywhere, even for what I expect to be a core part of the library, like array.indexOf. Naturally, array.indexOf was added to ECMA script 5, and hence it's in IE9. So, 1997, we get HTML4. I think I might have to start hurrying up. Internet Explorer 4 comes along, and we get the box model. God, I love the box model. Who here knows about the IE box model? Yes, IE box model is brilliant. So again, interesting piece of history I only learned while doing research for this talk. So Internet Explorer 4 and Netscape 4 were both agreed on the same box model. They said, okay, well, how do you measure a box? You include the border and the padding and the content, because that's how you would measure a box. And this is how graphical designers work too. So very sensible, they agree. W3C goes, no, you measure a box by its content. And so you suddenly end up where your browsers are out of spec, and so browsers slowly try and adopt the spec. So you introduce this thing called Quirks mode because Microsoft is obsessed with backwards compatibility, not unjustifiably. And you get this thing which is occasionally triggered, which says, okay, in Internet Explorer 5 or above, when certain criteria are met, you have a certain doc type, whatever, we'll enter Quirks mode and have the old box model, and otherwise you'll have the new box model. So new box model, only content if you're trying to measure width. Old box model includes border and padding. So, you know, this is not so bad. It's kind of an okay backwards compatibility thing. The problem is, Quirks mode is kind of hard to figure out when it triggers. So here's a list of exceptions. So this is IE6, behaves perfectly. You know, it uses the new and accepted box model, except when any of these 6 things are true. So when you have an incomplete document type declaration, okay, fair enough, that's the thing which is meant to trigger Quirks mode. But also when there are errors anywhere in the document. What an error might mean, I'm not exactly sure, but hey. Just a word on the images. I've pretty much every image in this talk is from Wikipedia. I forgot to do citations, but you get the idea. So, the partial epilogue of this is that this horrible box model, which causes web developers to tear their hair out because all of a sudden they need to figure out which browser you're using in order to figure out which notion of width they need to give you. We eventually adopt this box sizing CSS property, which lets you set to the original IE spec. Because the W3C, after years and years and years of sort of umming and ahhing about this, realized that IE had it right all along. So, but there's more to this story, of course. What happens when you have 2 standards for how things should work? So there's the original box model, which is content, the standards compliant box model, let's call it, which has content equals width. And there's the new box model, which has border plus padding plus content equals width. And some smart cookie goes, okay, well, the behavior on table cells for the original box model is kind of good, but the behavior for everything else on the new box model is kind of good. So what do? You add an almost standards box model, which is the third box model. And here's the kicker. Quirks mode triggering is browser dependent, so you won't know how Quirks mode or the original box model mode will trigger in a user's session unless you happen to know the browser and the Quirks mode bugs in the browser itself. Here's an excerpt from the Wikipedia table that shows you how to work out whether you're going to be in standards mode, Quirks mode, or almost standards mode by browser. As you can see, most browsers nowadays have at least standardized on that third column, which is really, really good. And as long as you're doing the right things as a website design, end up in Quirks mode. But if you do happen to want to support IE 5.5, then you've got a very difficult life indeed. All right, Internet Explorer 5 comes along, and what does it introduce? It introduces the float model. The float model is a little more obscure than the box model. Who's heard of the float model bug? Yeah, a few people? Okay, so the float model bug is basically Internet Explorer 7 and before didn't understand what to do with floats and statically aligned content. Sorry, do people know what I mean when I say float in the context of a website? Yeah, mostly nodding. So a float is basically just a way of saying, shove this thing over to the left and, ignore me, basically. So I'd like this to appear on the left. So you might do this with, say, images if you want them to sort of float over to the left or the right, and then want text to flow around them. And there's a series of rules that are pretty well defined for when things kind of flow around and when things jump to the bottom. Or just intersect with the floated content. So imagine float as kind of, in the absence of other rules, you take the content out and you shove it on a particular side of the screen, and everything else ignores it until you tell it what to do with it. So you see here the example of the correct float behavior for something that says float left, so that's the green box, shove it over to the left, and then having some static content listed after it. So the top shows you the correct behavior where it actually just ignores it, and the other ones show you the evolution of Internet Explorer fixing this bug. I don't know if you can see, but there's a slight change in the distance between the Internet Explorer sides, which changes from IE5 to 7. It turns out this is governed by this internal Internet Explorer only property called hasLayout, which is governed by a series of rules so intensely difficult and convoluted that it takes about a 5,500 word document to explain them all in the version Internet Explorer up to 7. I linked this doc at the end of the presentation if anyone's that interested. But here's an example of what it does. So there's a hidden property called hasLayout, which is triggered in various ways, which changes the float behavior of Internet Explorer. And the way this hasLayout is triggered, so the behavior in that 5,500 page doc is about 1,500 words. Then there's about 3,000 words dedicated to how to trigger it properly. So here's an example of triggering. So how do you know when something has layout in order to figure out what you actually want to do with it? Well, okay, width and height trigger has layout in IE5.x and IE6. Okay, good enough, but only in Quirks mode. So you've got this horrible series of rules that are absolutely impossible to know. So you basically, as a web developer, just muddle your way through and play guessing games until you work it out. There's also this hack. This is like an IE-specific thing that you learn, or you learnt when you had to deal with browsers like IE5, like IE6, in order to fix the hasLayout bug. So this sort of forces something to hasLayout. You can't actually introspect hasLayout, it's worth mentioning. You just sort of have to guess the value from the context. Problem, it doesn't work in IE5. So yeah, so you end up with these kind of, you end up, people have probably seen similar things. You end up with this kind of shim you import at the start of your code, which kind of fixes all of the layout. So at the very minimum, it's predictable for the rest of your web app, even if it's not nice. All right, Internet Explorer 6. How am I going for time? All right. So here's where we start to get into memory leak territory. I'm sure there were memory leaks before Internet Explorer 6, but they were really hard to find documentation on, so I figured I'd start with this stuff. Did I skip a few years there? Yeah, got the year wrong, it should be 2001. So JScript, our good old friend, comes back. So it turns out that because of the differences between JScript and other browsers, Internet Explorer has two garbage collectors, one which runs the pure JS. This differs from the majority of browsers at the time, I'm not sure of the latest, which have just a single garbage collector run that runs over both the JS and the DOM. The thing that this introduces is a series of horrible memory leaks, because if you have references between the DOM and the JS, they can't be easily garbage collected. As soon as you have a loop, the DOM garbage collector goes, aha, this is referenced, and so I can't clean it up. It's just a normal mark sweep garbage collector. And the JS garbage collector goes, aha, I can't clean this up because there's a reference to it. And so you end up in this place where you're just completely stuck, because neither of the mark sweep passes can completely run over the whole tree. So, this is an example of a basic memory leak. We've defined a function leak. We've got a JavaScript variable sitting in memory. that references a DOM node. And the DOM node, in turn, defines a property that references the JavaScript variable. To anyone who's been web programming for long enough, the second step of that, where you have attaching something onto a DOM node to reference JavaScript, kind of sets off alarms in your head because you know it's going to a memory leak. So, this is a graphical representation of what's just happened. That seems easy enough to avoid. The more insidious form of this is closures. So all of a sudden, this might be a little hard to read. So what we've got is we've got a function leak. We grab a DOM node and we chuck it in the JavaScript variable. And then we say, okay, DOM node.onClick equals function. So var foo is just fine because it gets cleaned up. That's a JavaScript variable that can be cleaned up whenever we need it to be. The problem is, because of the nature of JavaScript closures, the function has an internal reference to foo. And as a result, it's got a reference to the DOM node. So all of a sudden, you've got, by virtue of the function closure, a DOM node which is stuck inside the JS, which is in turn referencing JS. So all of a sudden you've got a loop. Oh, I didn't provide an example of that. So, memory leaks. This turns out to be, I looked through a brief history of Internet Explorer memory leaks. There's a lot of kind of crazy, insidious ones. There's one more I'll give an example of. But this is by far the most common one. I don't know what lesson there is to take away for browser designers here, other than have a sensible garbage collector that actually goes over your entire tree, which seems easy enough to me. All right, so we completed the first browser war. Netscape has kind of been trounced by IE, which was released free, and then then it reached feature parity, and IE was now dominating, and then there's pretty much nothing but IE for a while. So 2003 Safari launches. Our good old-fashioned function expressions come back, and there's this nice little snippet of 20-odd characters of JavaScript which reliably crashes Safari 2. No one really sheds too much of a tear because Safari 2 at the time was even less popular than Safari 5 is now. So, So Firefox launches, okay, now we're getting somewhere. We've got some serious competition coming along. And Google Maps launches, and the reason I specifically mentioned Google Maps, not intending to be self-serving, is because it's widely regarded as like the first Ajax app. And this sort of heralds a moment in computing where, like, all of a sudden you're writing these deep applications in the web browser, and all of a sudden things get way more complicated from a lot of perspectives, including security. And I'll go on to talk about security in a second. Internet Explorer 7 comes out. Oh, here we go. And have any of you seen, Michal, I'm not sure how to pronounce his name, Michal Zalewski. He's a security researcher. He's quite well known. He works at Google now. He runs this site called BrowserSec, code.google.com/p/browsersec, which basically documents how to do web application security. So it's sort of a reference guide for web programmers. Have you guys seen it? No? Awesome reference, just tremendous. So there's a series of wiki pages, and on them there's a list of cross-browser security flaws. Here's an example. This is a table of all of the cross-browser differences in security in terms of iframes of just basic HTML content. Everything that's red is not good. It only goes up to IE8, unfortunately. It only goes up to 30. Chrome is mostly up to date, I think. But it gives you an idea of, if you're a web application developer, say I work for Google, say I'm working on something with private sensitive information, which could be Gmail, it could be calendar, it could be anything. I want to protect the user's data. Makes sense? In order to make sure that the content can't be iframed in order to make sure there's no XSS vulnerabilities, I have to reference this table and go, is the security method I'm adopting sensible? And web application developers have got a series of tools in order to make this better, in the sense that there's kind of a lookup table. If you want to protect against XSRF vulnerabilities, there's one correct way of doing it, and you know not to use any of the other ways because they land you in hot water. But the reason they land is obscure and trapped in one of these tables. So there's no easy way to see when you're doing security stuff why something won't work ahead of time. Here's another example. So this is with regards to XHR connections. What part of the cookies of the user session what part of the cookies on the user's web browser you can actually sniff. Again, just completely hairy and inconsistent. Again, I'm not sure what to do about this. I'm not actually sure if there are security specs or things like that are detailed enough to actually capture this, but the fact that it's so different across browsers scares the hell out of me. It goes on, very worth looking at the entire list. I know when I started out doing web development, I kind of tried to memorize it and then just gave up and learned the best practices, but it's a really interesting read. Okay, we're up to Google Chrome. So at this point, we've kind of got 4 major browsers. Google Chrome takes off pretty damn fast, as I'm sure most of you know. So there's Chrome, Firefox, which is sort of rapidly gaining ground on Internet Explorer, and Internet Explorer is kind of, slowly dipping as people realize that, hang on, well, they really haven't done much in the last few years, and kind of, why don't they have tabbed browsing and all of this stuff? And Internet Explorer 8 comes along. Great. And we're back to memory leaks. Okay, so Internet Explorer 8 is great. So Microsoft fixed that bug I talked about earlier with the loop references pretty quickly. So they did something or other in order to make sure that it didn't happen. But naturally, there are other memory leaks. Again, IE specific. I did actually find one page. It looked a bit like Microsoft propaganda that was talking about the memory leaks that were in WebKit browsers that weren't in IE, but I actually couldn't tell what the bug was because the page read so much like Microsoft propaganda, like, aha, look, we found a vulnerability in these other browsers, isn't that fantastic? And I'm like, okay, well, there was probably something there, but I couldn't get through it. So in IE8, there's a few of these, there's a few elements where it's worth noting here that the thing I said right at the beginning. There's a few different kinds of memory leaks in browsers, and it's important to distinguish between them. So one kind is the kind where you've just permanently eaten up memory. Like, you close the web page or the tab and the memory is still gone. That's awful. The more insidious kind of memory leak is, the one that kind of builds up over a long-lived user session. It's not sort of, it's not a be-all and end-all leak in the sense that you might close the page and it might go, or you might navigate to another page. But say you're using something which you remain logged into for a long time, like your email or Facebook, and, well, this room is probably less Facebook users than normal, I guess, but it's, if it's that sort of thing, then, your memory over a long time could build up till your computer slows to a crawl. And that's kind of the insidious form of memory leak that I'm talking about now. So in IE8 and IE9 and IE10, if you create any of these elements and then remove any of these elements, the memory hangs around and they don't get deallocated. So if you happen to be doing something that, I don't know, a photo album viewer that needs to create and then deallocate a lot of images, then you don't actually get the memory back in Internet Explorer. I actually think the Maps API might have run into this bug with map tile loading, I'm not sure. It sort of stands to reason. So, I guess IE9 isn't the be-all and end-all, but... all right, this is one of my absolute favorites. Internet Explorer, I know it sounds like I'm ragging on Internet Explorer here. I don't intend to, I'm not intending to pick on Internet Explorer. It just so happens that in terms of... Okay. In terms of being divergent from the rest of the browser community, Internet Explorer did a particularly good job. So Internet Explorer, so again, Microsoft is very invested in backwards compatibility. They release a new browser. They force you to update to the newest version of the browser on Windows. Like if you get a new OEM model, you can install only one version of Internet Explorer, for example, and you can't do anything else. So what do? Well, they offer you a compatibility mode. If you've got Internet Explorer 8 installed, you can't install Internet Explorer 7, I don't think, except without some egregious hacks. So they offer you a compatibility mode which lets you run in effective IE7 mode. The problem is it doesn't work as expected. And this should surprise absolutely no one. I mean, if you're trying to perfectly emulate a browser in another browser, it's going to be really hard to get all of the bugs and things like that. I mean, just given the sheer number that I've already told you about tonight, it's not easy to reverse engineer a browser and make it work in another browser, even if they've got the same core logic, JavaScript emulator, and so on. So here's an example of a bunch of CSS properties that differ between IE8 and IE7 compatibility mode. And the upshot of all of this is with each IE release, we don't get one browser, we get at least two browsers. If they happen to be doing multiple compatibility modes like IE9 emulating IE8 and IE7, we get 3 new browsers as a web developer to each individually test on, because we can't assume that they'll replicate the same functionality. Which, I don't know, makes me cry. Of course, it continues into IE9 and IE10. They have gotten better, but here's an example of something IE9 compatibility, IE9's IE8 compatibility mode that doesn't work in IE8. You might have also seen stuff like HTML5 shim, which is worth mentioning just because it's the kind of thing that shouldn't be necessary, ideally, but it is necessary. So the HTML5 shim is this layer that we put on top of this CSS file that we load in at the top of web apps in order to make older browsers not balk at the new HTML features in newer browsers. So basically it tells IE7, when you see an article, it's okay, don't panic, it's just a div. And so obviously they're not going to be able to support video in IE7 with a simple thing like this, but you know, it at least gives you the flexibility as a web developer to kind of write what you want and give you the advanced semantics of the new tags in HTML5 without having to worry about browser backwards compatibility. This one I definitely don't have a good solution to unless we kind of universally adopt better browser deprecation timelines, which, you know, Firefox and Chrome and to a lesser extent Safari already have, but Internet Explorer with like its long-term support model is really not doing so well. Alright, Internet Explorer 9. So why is Internet Explorer 9 so good? Internet Explorer 9 marks the moment as a web developer when I finally stopped worrying about cross-browser stuff. Like, it wasn't front and center of my mind as I developed web applications saying, oh shit, what do I need to do to make sure this works on IE? Do I need, with every change, to run this on every browser? No, with Internet Explorer 9, I'm pretty sure if I write something in Chrome and test it on Chrome, it's going to work okay on Internet Explorer 9. It might not work great. There's still some cutting edge stuff which might not work, but my God, it's so much better. At Google, we only support the last 2 depending on the product, but at least on my team, we only support the last 2 versions of each major browser. So by the time Internet Explorer 10 gets released, I don't have to worry about IE8. And I can all of a sudden write these web apps that I've always wanted to write without killing myself. Yeah, so this is the point. Like, as a web developer, you're still stuck with IE6. It still exists. If you are writing the sort of product, Google search springs to mind, where you do actually get a certain amount of traffic from IE6. You know, it's an unavoidable part of life, and all of these browser bugs that I've talked about so far still bite you. So where are we now? Okay, well, I've already talked about like all of the horrible stuff. We're in a much better place now. Some of you might have heard about this Australian tech website, Kogan, that started charging when you wanted to purchase from this site. If you were using IE7, it charged you an IE7 tax I don't think they support IE6. And the rationale was that you were costing them so much having to support that browser that they felt like it was a good idea to say, look, either you can immediately hop onto another browser and make your purchase for cheaper, or you can pay a tax, which will pay our software engineers to support your browser. I don't know, I thought it was cute. I don't know if it'll catch on, but I feel like this kind of represents the kind of pain we go through as web developers. On the mobile front, WebKit completely dominates because your two platforms are the iOS native browser and Android, where Chrome is becoming the standard. So this is an interesting place to be because with only one browser, it of course removes a lot of cross-browser constraints for mobile web app development. It's going to be really interesting to see what Windows does to this. I don't know. That is assuming that Windows Phone takes off, which I'm also not sure about. It does make me cry that after so many years of trying to standardize internet development, we still have like disparate native app support on mobiles, which kind of is another hell completely for anyone who's tried to develop iOS applications, port them to Android and so on, but that's another talk. Videos are still an area of pain. I'm sure you all are very familiar with the video standards arguments. I'm not hugely familiar with them myself, but to a web developer, this is kind of one of the last vestiges of non-compatibility, because all of a sudden every time, you can do everything, but every time you want to provide a video, you have to provide it in at least 2, maybe 3 different formats if you want to actually have video support for the particular video that you want to show. Or you can just embed YouTube, I guess. And the last one is bleeding edge CSS. So like there's, I mean, I absolutely, oh actually I'm going to say that on the next slide. So, but CSS, it seems to trail behind the browsers a little bit in terms of the support that exists in the spec. So we kind of get this weird area where like different browsers support different sets of bleeding edge CSS. And for developing like a stock standard web application, that's fine. But if you want to have cool animations and so on, it's a real problem for web developers. I love this. This is probably one of the best developments we've had. I picked linear gradient specifically because it has kind of a weird syntax. Adam pointed this out to me earlier, that linear gradient actually differs cross-browser in terms of the trial implementation. But the fact that I as a web developer can go, aha, I'm implementing something, it only works in Firefox. That's huge. I mean, that means that as a web developer I can go, this is something I'm knowingly putting into my web application that differs cross-browser, and it's clear, it's obvious, and if everything worked completely cross-browser except for this small set of things, it would be perfect, because then I could use features that are kind of dodgy, but at least knowingly. And here's the sort of example of linear gradient fleshed out. You'll notice that Internet Explorer is slightly different, again, from the rest of the people. And that's pretty much it. I'm much happier than I was a few years ago. I hope this has given you some insight into kind of the things that have caused me to tear my hair out over the last few years. It's really been a huge impact on my development process, just seeing the changes in browsers over the last 4 or 5 years. So thank you. So got a bit of time for questions. I'll also leave the resources up. These were kind of the most helpful websites in terms of figuring out this whole story. I'll share the slides as well.
Hey, more of a comment maybe. There's this great other browser on Android called Firefox for Android, which I'm not. I mean, it's certainly not as popular as like the built-in browser and Chrome as well, but it's got some millions of people using it now, and it's slowly growing.
Yeah.
So I guess we didn't talk to, in the panel session earlier today, we didn't quite get to the topic about talking about the WebKit monoculture and whether that's a good thing or a bad thing, but I think it's something definitely to be aware of, that not 100% of people are going to be using like WebKit browsers on Android.
Yeah, and that's a really important comment, because I mean, web developers are pragmatic. If there's a browser with I don't know, 5% market share, it's kind of in that grey zone where web developers are going to go, oh, shoot, do we actually support this? Firefox historically has been great at standards compliance. So I mean, to a certain degree, it's been much less painful than your Internet Explorers, which is why me personally, I'm much more worried about Windows than Firefox.
So if you have a monoculture on mobile devices, each implementation is still too different at the moment. So you cannot really rely on one WebKit browser and say it works in all WebKit browsers.
Yeah.
Thanks very much for a really interesting exposition of the amazing diversity. About the diversity of approaches, why do you think there's such diversity persisting in all of this? Are there benefits? Is there resilience in the system? Or, I mean, do the different approaches reflect different local needs such that we shouldn't be expecting globalization and standardization across the globe? Just wondering.
Yeah, I tried to think about this as I was doing it, and the more I thought about it, the more I was just plain surprised that the web has already reached such a level of standardization. I mean, maybe it's just me, but you look at anything else, I mentioned like already iOS native apps versus Android versus Windows. I mean, the internet is the one example I can think of where we actually have a really standard way of operating, and I'm what we did to make that happen successfully. Like the fact that Internet Explorer stopped being as sort of divergent as it was and is now, reasonably standards compliant in pretty much all of the major areas. I think that's a huge.
Hitting them with a big stick.
Yeah, but I mean, it's a huge achievement, right? It's amazing because we haven't been successful in doing that in pretty much any other platform that I can think of. Maybe other people have examples.
Yeah, just to first comment about the WebKit monoculture. Yeah, I'd agree that I don't think there is really any, because there seems to be such a huge divergence in which WebKits, up through the fact that current Androids ship with 2 WebKits, depending on whether it's the Chrome browser or if it's one of the apps that happens to embed the WebView. But I just wanted to ask you what you thought about the current kind of 4-browser balance, like whether it'll last, because basically when I was looking after a website in the last 5 years, it went from IE dominance with a bit of Firefox to when I stopped checking the web stats, each of the 4 major browsers were pretty, like within plus minus 5% of each other. Do you think that's going to be a stable thing, or it's not going to be possible for developers to keep testing on 4 different major browser versions, so people are going to start diverging again between, like, say, the WebKit camp or...
So I'm not a futurist. I think if there's a major change in the browser sort of balance, it'll be driven by users and not by developers. So developers will follow wherever there's usage. One of the interesting things I observed is that I think Chrome's the dominant browser by most metrics now, but by country, there's a lot of variety. Australia is still majority Internet Explorer, and other, Russia, I think, is still majority Opera. There's this great diversity across countries, which I think for the moment will keep browser developers sort of hot on each other's heels. I don't know what would cause one browser to be particularly dominant unless there was just some amazing killer feature that some browser developer thought of that all users must have. I think at the moment they're all pretty feature complete, and the rationale to drive users from one to the other, I'm not sure if it's there at the moment.
I think we're out of time now.